food chains. It has to be said that these aren't terribly complicated. A basic food chain looks like this. And if you were working towards an E grade, for example, then this is the sort of thing you'd be expected to be able to simply describe. But look out for some of those basic mistakes. One of the classics is putting these arrows back to front. If you turn that arrow around, it means that, well, the grass is eating the rabbit. And that means the rabbit's eating the fox if this arrow is the wrong way around. So look out for stuff like that. You lose marks that you really don't deserve to lose. However, food chains tell us quite a bit more. One of the things you'll notice if you look at examples of food chains is most of these food chains tend to run out of animals once they get to about 5 or maybe 6 organisms. I'd be surprised if you can think of one that's more than about 6 organisms long. Because here's why. If we take this simple food chain, at each stage, energy is lost. Because all of the things in this food chain are busy being alive. So, this grass, it's photosynthesizing, but it's also respiring. And that means that some of that energy is wasted. The rabbit is respiring too. It's keeping itself warm. It's losing an awful lot of the energy that it got from the grass as heat. And the fox, well, again, it's alive and respiring. So it loses quite a bit of energy. But don't forget, these animals are also excreting. So quite a lot of the raw materials that they consume from the previous organism in the food chain get lost as waste. So bits of the rabbit that the fox either didn't eat or couldn't digest or whatever. Now that's why food chains are quite short, because from one stage to the next there's only about 10% of the energy passed on. So quite simply, by the time you come to the end of a food chain, there just isn't enough energy to keep that many animals alive, especially because they happen to be getting bigger and bigger as you go.